Stored procedures are essential for automating tasks within Snowflake. They are named, parameterized blocks of code stored directly in Snowflake's database. These procedures encapsulate logic for tasks such as data transformations, ETL processes, and triggering workflows, reducing network overhead by executing code on Snowflake's compute layer. This video will focus on creating and calling stored procedures using Python and JavaScript. A stored procedure is a server-side script that encapsulates logic for automating tasks in Snowflake. It runs directly on the compute layer, reducing network overhead by processing data in place without moving it to external systems. Stored procedures can be written in multiple languages, including SQL, JavaScript, Python, Java, and Scala. This flexibility allows developers to choose the best language for their specific automation needs. When using Python or JavaScript, Snowflake's Snowpark API is utilized. Snowpark allows interaction with data as data frames or tables, enabling seamless data processing and transformation within the stored procedure. These procedures can be triggered by Snowflake tasks, which are scheduled jobs, or external tools like Apache Airflow. This versatility makes stored procedures highly adaptable for various automation needs in data engineering and analytics. To create stored procedures with Python in Snowflake, you'll use the snowflake.snowpark library. This enables data processing directly within Snowflake, leveraging Snowpark's DataFrame API for efficient operations. Here's a complete example of creating a stored procedure. First, import the session class from snowflake.snowpark. Define a function that takes a session and a parameter. The session represents your connection to Snowflake. Inside the function, create a data frame from a table, filter it based on the parameter, and save the results to a new table. Finally, register the procedure with Snowflake, specifying its name and any required packages like pandas. This code registers a procedure named myPythonProc that filters data from myTable based on the provided parameter and saves the results to result table. Make sure the session object is properly configured and you have the pandas package available in your Snowflake environment. Stored procedures like this fit into broader data workflows, as shown in this flowchart, where they handle dynamic data processing within Snowflake. Creating stored procedures with JavaScript in Snowflake uses the snowflake.createStatement API to execute SQL commands directly within the procedure. The procedure starts with the create or replace statement, specifying the name and parameter type. It defines the return type as string and sets the language to JavaScript. The procedure body begins with the as keyword and $ for the JavaScript code block. Inside, it constructs a SQL command string using the parameter to filter data from myTable. It creates a statement object with the SQL text and executes the query. Finally, it returns a message with the number of rows processed. This JavaScript procedure, called myJSProc, takes a parameter, constructs a SQL query to select data from myTable, executes the query, and returns the number of rows processed. The data flow involves loading and transforming JSON data before processing in Snowflake. Once created, you can invoke stored procedures using the call statement. For example, you can call a procedure like this: call myPythonProc with a parameter value. The parameters passed to the call statement are input variables for the procedure. Procedures can also return values or modify data depending on their design. Remember that Snowflake automatically handles transaction management with automatic commits, unless explicitly specified. Effective error handling is crucial for reliable stored procedures. In Python using Snowpark, you should use try-except blocks to catch and manage exceptions. This allows your procedures to handle unexpected errors gracefully instead of crashing the entire operation. For JavaScript stored procedures in Snowflake, use try-catch blocks to handle exceptions. This approach allows you to catch errors and provide appropriate responses or logging, ensuring your procedures remain robust even when encountering unexpected issues. To optimize performance, leverage Snowflake's built-in caching mechanisms for frequently called stored procedures. This allows the system to reuse results from previous executions, reducing processing time and compute costs for repetitive tasks. Thorough testing is essential for stored procedures. Test them under various conditions, including valid and invalid inputs, error scenarios, and performance with large data sets. This comprehensive approach ensures your procedures function correctly and handle unexpected situations. Ensure your stored procedures run in Snowflake's sandboxed environment. This provides isolation and security, preventing procedures from interfering with other system components or data while maintaining a controlled execution space. Many companies leverage stored procedures for automation tasks in real-world scenarios. For instance, Walmart uses Python stored procedures to automate daily inventory updates, reducing manual errors by 60% and saving $2 million annually. A major health insurer employs JavaScript stored procedures for HIPAA-compliant data anonymization, efficiently processing over 1 terabyte of data daily. These examples highlight the effectiveness and adaptability of stored procedures across different industries and use cases. The integration of AI/ML is a significant trend in stored procedures. They are increasingly used for automated machine learning pipelines, with Snowpark enabling direct calls to popular libraries like scikit-learn within procedures. Looking ahead, Snowflake plans to expand support for more programming languages and integrate with emerging technologies, such as quantum computing simulations and real-time streaming via Kafka. Experts predict stored procedures will evolve toward AI-assisted coding, where Snowflake's Copilot tool suggests optimizations and helps write more efficient procedures. Keep an eye on these developments as stored procedures become even more integral to data automation in Snowflake.